Good morning, everybody, and welcome to our lesson today on ions. Yesterday, we took a look at isotopes and we went through and we determined whether or not given atoms were atoms of different elements or isotopes of the same element based on the number of neutrons in the nucleus. Today we're going to take a look at ions, and most importantly, I want to tell you why we are taking a look at ions. Because looking at your faces yesterday with isotopes, you kind of got how it worked, but I could see that question why. Let me see if I can answer that today with ions as we go through. And the beauty of this is, yes, we are going through it in video form. So for those of you playing the home version of our game, you can hit pause at any time, and in class I'll be hitting pause too to wait for your responses. So let's take a look. What are ions? To start off with, to review everything we've been talking about so far with atoms, you've heard me use one word. We said everything we're talking about right now, the number of protons equals the number of electrons, therefore it is a what type of atom. And that's what I mean here. Overall, atoms have a neutral charge. And what we've said all along is when we take a look at that atom, in the nucleus you have the protons, and the protons have a positive charge. The electrons have a negative charge. And every atom we've looked at so far, the number of protons equaled the number of electrons on the outside. So the atom had a neutral charge, and overall atoms have a neutral charge. Today we're going to take a look at ions, and that's where things are a bit different. Okay, one thing we need to remember going forward is to be stable, atoms need to have 8 electrons in their outer electron shells. Now take a moment, take a look in your notes, and see if you remember we talked about the orbitals or shells of electrons and how many electrons could be in each orbital. So take a second right now. If you're playing the home version of the game, go ahead and hit the pause button, check your notes, and see if you can find how many electrons in each orbital or shell. And we're back. So in your notes, you should have found that we had, and yes, in class we found here too, that in the first orbital you have 2 electrons. In the next orbital you can have up to 8 electrons. Third orbital you could have up to 18 electrons, and it will continue. But in order for an atom to be stable, they need to have 8 electrons in their outer electron shells. Now I'm going to teach you a little nasty word here that the great curriculum writers in the sky don't necessarily want you to know right now, but it's one you're going to hear in the future, so I'm going to go ahead and give it to you. And it is valence electrons. That outer shell is the valence electron shell. You're going to hear that term in the future, and it's an important one to know. But right now it's not in the curriculum, so shh, but you know it, okay? It is valence electrons. So let's take a look at an example. Chlorine is our example. And this is another time where if you're playing the home version of our game, you might want to hit the pause button, because I want you to find chlorine on your periodic table. Because that first line, it says chlorine has blank electrons in its outer shell. So for the first thing you want to do is take a look at chlorine on your periodic table, find the atomic number. Because everything we've been doing so far are neutral atoms, so the number of protons will equal the number of electrons. Therefore, the atomic number will tell you the number of electrons overall in a neutral atom. But then you're going to have to do a little calculation with the number in each orbital to find out how many are in its outer shell. So take a second right now, look that up, and see if we can find how many electrons are in chlorine's outer shell. All right, nice job, ladies and gentlemen. Yes, if we calculate, there are 7 electrons in chlorine's outer shell. we found 17 is the atomic number in a neutral atom. That means there are 17 protons, 17 electrons, 2 electrons in the first shell or orbital, 8 in the next for a total of 10. That leaves me 7 to go in the outer shell, otherwise known as the valence shell. 7 valence electrons. We said earlier, to be stable, it needs to have 8 electrons. So some high-speed math here, guys. When it gains, how many electrons will it become stable? I'll give you a second to get your calculators just in case. Yep, when it gains 1 electron, it becomes stable. So this means that the chlorine atom is now negatively charged because it has more electrons, negatively charged electrons, than it does protons. So the overall atom is negatively charged. And that, ladies and gentlemen, is what we call an ion. So let's take a look. To review, I said an atom has gained an electron. It now has more electrons than protons. It now has a negative charge and is called a negatively charged ion. I want to teach you another nasty word here, one that's not necessarily in the curriculum, but you're going to see it in the future. And that is anion. A negatively charged ion is an anion. Notice what I underlined there. It's a way for you to remember. A negatively charged ion, anion. So a negatively charged ion is an anion. So that's when an atom has gained an electron. Some atoms may lose electrons. And in that situation, if an atom has lost an electron, it now has more protons than electrons. So it now has a positive charge and is called a positively charged ion. Yep, you guessed it. Here comes another nasty word. A positively charged ion is called a cation. And notice what I wrote, a positively charged ion. Think of the paws of a cat to help you remember it. So if it's positively charged, it is a cation. Okay, so those are 2 words. Don't tell anybody I taught you those words, but you're going to see them in the future along with valence electron and valence shells. So that takes us through what ions are. And before we jump into practice, I know that's not enough for you guys because you want to know the why. Why do we need to know these ions? So let me give you a little view into the future of where we're going. Okay? And we're going to come back to our chlorine atom. And what I told you we need to remember is to be stable, atoms need to have 8 electrons in their outer electron shells. We looked up chlorine, saw the atomic number of 17. It has 17 protons, 17 electrons. And in their shell, first shell, it has 2 electrons. Second shell, it has 8 electrons. And then there are 7 electrons in that outer shell, otherwise known as the, don't say it too loud, valence shell. Okay? Well, that's fine. That's just a repeat of what we did. But to show you where we're going after the holidays and give you an idea of why we're doing this with ions, well, let me introduce you to sodium. Take a second right now. We see we have sodium on the, you could check it on the periodic table. It has the atomic number of 11, so it has 11 protons and 11 electrons. I'll give you a second now to go ahead and figure out how many electrons are in each shell. All right. I know there's 11, so you had 5 fingers on one hand, 5 on the other. You might have had to kick off a shoe, but I think you were able to do that math. And you would add 2 electrons in the first shell or orbital, 8 in the next, and then in the outer shell, there's only 1 lonely electron. You get where we're going here? All right, let's take a look at it in pictures. Here is our chlorine atom. We have 17 protons in the nucleus. We have 2 electrons on the first orbital, 8 on the next. And then you see we have this one lonely spot right here where it has room for one more. And to be stable, chlorine really wants that extra electron. Now, back in the old neighborhood, we would say this chlorine atom is one sandwich short of a picnic. It's not stable. But in the chemistry world, we'll just say it needs that extra electron to be stable. Well, let's take a look at our sodium. Similarly, we have 2 on the inner shell, we have 8 on the second shell, and in that outer or valence shell, we have just 1. So I'll give you a second. Let's see if we can come up with any possible solutions for both of these atoms, sodium and chlorine, and how we could solve their issue where they could both be stable. That's right, you got it. Simplest solution is, what if we take the 1 from the outer shell, because sodium wants to be stable. If it gives up this 1, take a look. This is now the outer shell, and it's got 8, so it's stable. If that 1 comes over here, now this is a complete outer shell for chlorine. And we have 2 stable atoms. So let's take a look at what that would look like when that happens. Notice the outer shell for sodium goes away. We have a full outer shell of 8, and we have a full outer shell of 8 for chlorine. So we know now this has gained an electron. So what's the nasty word for that? Yes, it is an ion, a negatively charged ion, because the chlorine now has 1 electron more than it does protons. It has 18 electrons and 17 protons. So as an anion, chlorine also changes its name a little bit. This they'll tell you about later too, and we'll talk about later. But once it is a negatively charged ion, we'll refer to it as chloride. Change the name a little bit from chlorine to chloride. And when we come over here, the sodium has lost an electron, so now it has that positive charge, and what's the nasty word for it? That's right, cation. It is a positively charged ion. So I have a positively charged ion, a cation, and an anion. A positively charged ion, a negatively charged ion, and we all know opposites attract. Hey, these two have worked together to solve a problem, so they have a bond. They're going to hang out together. Positive charges and negative charges tend to come together. And that, ladies and gentlemen, is how we get sodium chloride. Another interesting thing, next week as we look at families and groups on the periodic table, take a look at where sodium is on the periodic table. Take a look at where chlorine is on the periodic table. And you'll notice that everybody in the same column has the same number of electrons in the outer shell. So everything we're doing here is giving you all the ingredients so that after the holidays, when we talk about compounds, you could put together all different combinations. Okay? This type of situation we have here, since it was 2 ions that were formed that came together, this we'll talk about after the holidays is an ionic bond. So, ladies and gentlemen, this is the why we are taking a closer look at the ions today. And in our practice, you'll have examples of different atoms to determine whether they are anions or cations going forward. That, ladies and gentlemen, takes care of our notes on ions. Again, since it's in video form, you can go back later and watch it. Those of you that are playing at home can go ahead and rewind it as well as you need to jot down any additional notes you'd want in there. And next up will be some practice. And I'll give you some examples before we jump right in.